Hello everyone, I am Bradley Sward, Associate Professor of Computer Information Systems at the College of DuPage in Glen Ellen, Illinois. And this video is part 4 of a series in which we're going to be making a game called Boxxle or Sokoban, depending on your frame of reference. And we're going to convert it into both GameMaker Studio version 2 and then port it over into C++ SFML engine running the game. So we've already done a few of the previous steps here since this is part 4. We've already gone ahead and produced the game in GameMaker Studio version 2. So go back to those videos if you need to fall back on having that working for us. Remember the game is in 720p resolutions, so 1280 by 720 resolution, and each of our tiles are 60 by 60 size. And again, this video you don't necessarily have to worry about any of that stuff, but just as a just a remembrance of what we're working toward. So this video, for my students at least, I already have a working zip file, a Visual Studio project set up for them. And if you do not have that, you'll have to go ahead to this website, sfml.org, tutorials, blah, blah, blah. You'll find it here. And you'll have to go ahead and make sure you can get everything working. I am terrible at setting up development environments, so it always takes me a while, so thank goodness I have a working version I can fall back on. So again, this video will not cover any of the installation steps, but I can tell you in my example I have it installed into my Visual Studio project, so I don't have to have it installed anywhere else. I can kind of take it with me everywhere I go, and as long as I have Visual Studio installed, everything works fine. So this video is going to take a look at this. This is like the Hello World video or program when it comes to SFML. So this is basically your first step, is just to make sure this is working, this file, and we'll come up to this here in a second. And so this is just something that's going to put a window, a secondary window up on the screen. It's going to draw a red or green or whatever color circle, and then a little bit of this, a little bit of that, and then you can see everything else that's going to go on. So the first step is just making sure this thing works. That's the Hello World part of it. And then we're going to start taking this and start working toward building this into a game class, because this is an object. Our main goal here is to create an object-oriented framework / game engine. So we can take this and start building it into a game class, and then take that game class and advance upon it and start doing other things that we need to worry about for the rest of our coursework here. Okay, so here is my working version. I can prove it's working. So I went ahead here. I just added this real quick, and so there's my circle, my red circle it's drawing, and then there is my bunch of dot, 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 dot. And so while window is open, draw a dot, do some stuff, draw the screen, and repeat. So this is going basically as fast as it can go, and there are ways to determine what kind of frame rate we're getting, but I would be willing to bet minus the C out. This thing's actually slowing the thing down. C out is like the slowest thing you can ever do, especially if you're trying to print one character per game frame. So that's actually slowing down the program quite a bit. But I just wanted to show it was working, at least on my end. And so now we can take this and start thinking out, how can we break this thing down into separate functions, into this game object that we're going to be creating. So I'm not going to worry about the game object just yet, but I'm going to start thinking about all of the functions that are going on here. So, and just stuff that needs to go down. So if I'm thinking I have my window, this is exactly what you might think it is. This is what's setting up. Let me move this into the global, because these are eventually going to become our member variables. But so this my render window, I can say, well, 400 by 400, what does that do? That actually changes the window size, right? So coming back to here, instead of it being just the size of our circle a minute ago, now it's 400 by 400. So just to get going, if I'm going to be creating a 720p environment, I probably should set 1280 by 720 as my range. And there it is. There's my working window. And as I say, the C out window is sitting there in my other screen. I'm not going to move it over every time, because right now this is all that's important. So there you can go. These two settings here change that. And also this here, I can say, like Bradley Sward copyright, I don't know, just 2020. And I could run that. And so this actually is the title bar. Bradley Sward copyright 2020. So you get your width, you get your height, you get your title bar. That all comes for free if you set everything up appropriately. Okay, so then here is my shape object. And you could play around with this. This is just to get things going, and then we're going to move over to sprites and we'll never look back. But if you really wanted to change the size of this is probably the radius. So there's my little bigger there, right? 200 pixel radius, or maybe it's diameter. It's actually probably radius here, or whatever, who cares? But there I can move that above, and then kind of everything else kind of will come along here. So just thinking back to GameMaker, all the different events that our game runs. We have our create events and step events and draw events and all sorts of stuff. Our goal is to, our end goal is to create a very mini version of the GameMaker Studio engine. So we're not going to go absolutely as crazy as they are, but just for the moment, let's kind of think about grouping these things together. What about this thing, a fancy little thing called a draw event, or a draw function? What if I stole all this stuff here? Clear the window, draw the shape, display the window, and what if I brought everything up into here, right? So as long as window exists here and everybody's happy. And so what if I then just call the draw event in its place, right? I'm just kind of reducing down. And yeah, of course, this is the refactoring stage, this whole discussion today. So yeah, the whole goal right now is to kind of reshape everything, refactor everything to get us to the exact same spot we were a minute ago. Okay, so cool, we've got that going for us. What about this kind? Let me get rid of the C out here. And what about this stuff? This stuff you might not be used to, and I'm really not used to it either because of the environments that I work in. But you know, when your program is running, the operating system is working alongside of you. And if you've worked in GameMaker, you can actually start halting systems, and you can start causing a lot of problems if you hit an infinite loop, because you never get out of that infinite loop. You can never get out to any of the other any of the products and any of the other objects to do the work you're trying to do. And the same thing works here at this level. Like if I just, Windows is very nice to me and takes over and lets me take over what's going on in my program. But if I never give back any control to the operating system, if things are going on inside, events, right? Event-driven architectures, if things are going on, if I'm clicking, or if other events, other activities, other tasks are working behind the scenes, that's a problem. What if, like with this, what does this do? If this lets me close down the window. So this the event here is I'm trying to tell the operating system that I am done with the program by clicking that X. And so if I comment out that, the event gets triggered, but I can't do anything. I can never get out because there's no code to tell operating system, hey, we're done, or at least tells SFML, hey, the window wants to close, and then from there we'll work with the operating system to see what we need to do. So I like to call this process events, and I don't think we ever need to touch this after we move this over. Oops, sorry. Okay, so then, and really at this moment it doesn't matter where we put things. Process. And so I can get, this would be an infinite loop or a Stack Overflow right away immediately. So then just make sure we call the process events. Cool, fair enough. And we're right back again to where we were. Fair enough. And so now I'm pushing forward again. Okay, now this while loop, this is the game loop. If you want to think of it that way, this is while my window is open, just do stuff as fast as humanly possible, or computerly possible. And we're going to see once we kind of refactor this and move things over, the final step is to make this thing a step-based architecture instead of just a non-step-based architecture. So, but anyway, coming back, I'm going to need a step event. And just for the time being, let's just put even though this is unnecessary, I'm just going to put this in here. Set the fill color of my shape, which is the circle. And so just to get things going here, while process events, do my step and do my draw. And this is just to have something to fill in the space here. And the shape obviously right now exists as a member variable, if you want to think of it that way, and so does the window. Okay, so but then coming back one final time here, the game loop, I'm just going to call that function run. And so all I'm going to do here is take everything you see here and bring it into the run and just call run. Crazy, right? Look at that. Wish it were that easy for just wish I could write a function that just says, you know, Elder Scrolls 6, run. And it would just run, right? So there we go. We're exactly where we spent all this time and effort, 10 minutes or so to talk about it and do all this stuff. And we're exactly back to where we were. And so now we have just one function that does run, that does all of the work. And so the run is our game loop, if you want to think of it that way. Game loop, and then everything else draws and process events and sets everything else up. So at this point, I am prepared to start moving this thing over to its own object class. So I'm going to create a new item called, I'm going to call it SFML game. Or if you just want to call it game, but I'm just going to, I've been doing this for years like this, so I'll just call it SFML game. And so class SFML game. And just start moving the stuff over, because ultimately the whole point is to make a class out of this as well. So let's see. So my member variables, these guys. And so public, private. And again, this is just our first stab at everything. So we need a render window, but we definitely need access to this HPP class, you know, the file, because it doesn't know anything of what I'm talking about here. So there's my render window and all this extra stuff. And this is just kind of nonsense stuff because you're never allowed to kind of set these things up this way, right? I need a constructor to do this work right now. So, okay. So just to kind of get this going, and I can steal this one more time just so I can set up a window, and I set up a shape. All right. Oops. Okay. So now setting up the constructor for this thing. All right, so using everything we know, set up my render window and set up my circle shape. Put a comma here instead of a semicolon. Here, let's bring this over. Let's see. Oops, get rid of that semicolon as well. Okay, so let's see. Does that build? Should be pretty good. Whoops, 8 errors. Window. Oh, yeah. We'll work our way. Again, we're working our way over. But right now, you know, everything is hard coded, which is fine for the moment. We're just baby goose stepping our way over. So there's our constructor that takes care of this and sets up the window and sets up our shape. And so that's our constructor. And then we'll need all these other events here, or these other functions, right? We'll need public function, public function for process events, a public function for draw. I can spell, really I can. And then one for step and one for run. And that's everything we've got going for us here. So we can kind of steal all these and just move them on over, right? And then move this over to the CPP land and fill in the gaps here. Just say, okay, SFML game. Got to make sure we tell everybody what we're doing here. This is this, this is that, this is this, this is that. And let's see how that fixes everybody up. All right. And so now that should do it, you know, when it comes to setting up and moving everything and kind of just getting everything into an object, into a class. And so now I don't need this anymore. I can just go ahead and use the SFML game, and I can just set up a SFML game object, and I should use a pointer for this. SFML game pointer game equals new SFML game, and make sure I delete game immediately before I finish anything up, and then I can say game arrow run. And so, my goodness, even more hard work, right? So and then now we're, after all of that, we are right back again to where we are. Just if you want to prove it to yourself, you can just change something, just add a couple B's, Bradley. And then there it is, there's my BBB Bradley. So everything is working. And it's a one or two liner over here, basically, if you want to think of it this way. Main has been reduced down to as simple as you can get. And this run function does all of the work. And so, at least to get going, this is the end of the beginning of the object-orientedness of everything. And so now we can discuss the idea of changing the architecture around, changing this run, so that we can handle clock the clock timer so this game can run at a different frame rate than as fast as it can possible. And again, game systems, engines like Unity and Unreal and CryEngine, the modern way of doing things is to work on a non-fixed step time scale, but it's simpler, at least from a learning standpoint, to just break it down and say this game will try its best to run at 60 game frames per second and handle it in that manner. And so it's not that it's, it's 6 of one, half dozen of another, but you'll notice that we're doing things differently, we're mimicking GameMaker, so we're going to keep to that. And so a few things that we can do to make this work. I'm just going to steal some code because I have my working copy over here. I am going to borrow this here. So I'm going to have float frames per second, 60 game frames per second, F, and then I'm going to have this time, that keeps track of stuff here. And again, this is just to get things going. I'm going to make this static, and I'm going to make this non-static. And so by making frames per second static, I can bring things up here, and for the moment here, I can say, oops, float SFML game S::, what did I call it already? Forgot what I called it already. Called it time for called it frames per second. And say there's my 60.0. So there's my default. And then I can bring down here, make sure I do everything correctly here. This is, put the statics up front, and then move this around here and say, okay, time frame, and then fill in the gap. Oops, do I need to, no. Okay, hold on a second. I need to just go back here and just steal this from my other video here one more time, and put this in and just say, time per frame is SF seconds 1 divided by. So this is basically turning this into a fractional amount of seconds. And if I'm running at 60 game frames per second, that's 1/60th of a second. 1666 milliseconds per game frame is the goal of what we're trying to accomplish here for how much time should elapse before each game frame should go. And so the only place this needs to be affected right now, the way things are set up, is here in the clock class, or in the run function, and set things up. So I need to set up a clock object, and you probably could use the one that you could find. You could probably look up how to time things, and I do this when I give stuff away to students in homework assignments and whatnot to see, like, test how fast this is, A versus B. And it probably works just fine, but there's a SFML version of it, so I'm just going to go ahead and use that. So I'm going to set up a clock, and I'm going to set up how much time has elapsed since the last time I ran a game frame. And in this case, I'm going to say 0 time has passed, because it really hasn't. So just setting up the variables that don't need to get initialized every time I run through my loop. Okay, so then what are we doing? So like every time I fly around, I'm going to need to know how much time has passed since the last time I got here. And so then you can use this function and just clock.restart returns an SF clock variable object, and we're just going to add it to it. And so time is going to elapse like you expect, 2 milliseconds, 3 milliseconds, whatever it is, every time it comes around. And so it's just going to add to that. And I'm going to process the events, because again, you never want to choke the Windows handler, because if you do, have you done it enough where something is sitting there churning, like Word or something, or Excel, sitting there and it's like not processing or whatever, not responding, and that's what you can do very easily if you're not careful. And instead of the computer actually fixing that, because if you never break out of this loop or you never actually process the Windows events, you have a huge problem. But really, realistically, all I'm trying to check for is to see if, and you can change it to a while if you want, but if the time that has elapsed total since the last time I updated and drew everything, if that time is more than the time that it's supposed to take to do it, then I do it. Right? So if the time since my if you want to think of last step, update, draw, step, whatever, however you want to name these things. And so I like to use a while, because then if it needs to catch up, it'll catch up twice immediately in a row. So I can say, and each time I have to make sure I subtract off the amount of time it took per game frame. Because maybe I missed 1 frame, maybe I missed 5. I mean, things can go terribly, terribly wrong sometimes. And so the only thing is I want to make sure I draw every time I come around, not just when it updates. I want to keep drawing. So that's the difference between a 30 frame rate or a 60 or a 120, is that the game, even though, it'll keep drawing even if it doesn't need to necessarily update. And just for the sake of this, if I get through all this and just process events, and again, it's just one if statement. I mean, it's really not that big a deal, and you're never going to notice things. And if you do end up noticing things and you change this around and whatever, just let me know that you did something like that and it actually sped things up, because I really don't know. It's one of those things that works for me. It works enough. I've never stress tested this thing enough to know we never get that far to try to make the best, fastest engine possible. Okay, so just to say here, let me just, you remember how fast that ... stuff was going earlier? So now, oops, I'll have to put in the include here. Let's put that dot in there. Put that C out, and you'll see how much slower now things can go. Because it was going hundreds of times a second a minute ago, or 10 minutes ago, or whatever. And now you will see, instead of going flying, 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 you will see, there's my box, there's my graphic, and there's my dot going about 60 frames per second. And you can try it out, like, I want to go 1 per second. And you can now see that dot, dot, dot. I'm not a metronome. Dot, dot, dot. And you can see everything else is going on like I expected to. So that's great that I can now affect my frame rate. And 60 frames per second is the standard these days, of course. And so, but now you see that everything else is kind of working, and we kind of have everything going. And so now we have 3 separate files. This guy here, all this does is set up the game, start the runner, and then when we finally click out and exit the program, we come back, delete the game, and then quit the program, and everything is handled just like it was way back in that first 20, 30 lines of code. And of course, this is more complicated, but we're getting ourselves ready for the next steps and ready to push forward. So for you guys who are my students, your job now is to take this and turn this into a singleton class, because essentially there's only going to be 1 game at a time going on. I mean, of course, I'm not going to get into arguments. Does singleton, is that a good design pattern or not? I'm using it. That is my experience out in the world. We use singletons all the time. I don't care what you have to think about that necessarily. But I want to be able to access the game from anywhere in my game. I don't want to have to pass it along all over the place. And so that's the next step, is that. And then that'll be my next video. And then the video after that will be how to go ahead and also change some stuff around here, so we can change this to make this more, change the frames per second, change the frames, change the resolution size, change a little bit of this, a little bit of that. And then I'm also going to add in keyboard and mouse events so that we can handle, handling input, because we're going to need input, obviously, to make a game, and we're going to create a little keyboard and mouse engine. So that pretty much covers everything that I wanted to cover for this video. If you have any questions, shoot me a comment or shoot me an email, and I'll get back to you as soon as I can. Thanks, everybody, and we'll see you next time.